Hey everyone, you're listening to the Simple Electronics Podcast. I'm your host, Dan from the Simple Electronics YouTube channel. This episode is sponsored by PCBWay. More on them later on. Today I've got a very special guest, Tim. How are you, Tim?
I'm doing very well, thank you.
Thanks for your patience. The people at home wouldn't have heard it, but I've actually had to do the intro twice, which is kind of new for me. So for those of you who, for the listeners that don't know you, can you just give us a brief intro of who you are, what you do, and maybe where people would have seen you before?
Yeah, definitely. Thank you. So my name is Tim. I go by Foamy Guy on GitHub and Discord and a couple other places online. I am a member of the team that works on the Circuit Python project, which is an open source project that allows you to run Python code on little tiny computers called microcontrollers. I work full-time on Mondays. So one day a week, I work full-time on the Circuit Python project, working on software, libraries, documentation, meetings around all of these things, and much more. I stream a lot of this work on YouTube and Twitch, so some folks may know me from there. In fact, one of the relatively frequently involved members in our community, Johnny Bergdahl, that is how I was introduced to you in this podcast. Johnny sent me your way. So I'm excited to be here. Thank you.
Oh, thank you for being here. And yeah, Johnny actually scored me quite a few of my guests. I think it goes pretty much. Johnny has got me the most guests, and then I would say that Scott, the Def Palm, not Scott Shawcroft, which you know, got me the probably most exclusive guests. So Johnny Bergdahl is like I guess a shotgun where it's like a blast of like everybody who's online he knows, and then you got Scott the Def Palm who just opened those doors that usually can't be opened. So it's pretty interesting.
Nice.
So let's start from the beginning then. I tend to like asking the sort of like software side people what kind of education they have at the beginning of the podcast. So what kind of education do you have in case people want to follow your footsteps?
Yeah, definitely. Great question. So I have, I would say, relatively little education as far as the software world goes. I learned Java in high school. I consider myself very lucky to have been able to learn Java in high school. I graduated high school in 2006. A few years after that, Android came out. I picked up the first Android phone when it was first released, and I kind of took what I had learned from Java and taught myself how to build apps and other software with Android. The only actual schooling that I have for software development is just community college level. I have a 2-year degree in computer programming from my local community college, but I have not gone any further than that in the education world. But I certainly am always learning stuff on my own, online, and through streams and all sorts of places. So, relatively little in terms of formal education, but have been working full time now in software development for just over 10 years, which is amazing to look back and think about.
Yeah, that's pretty neat. 10 years, huh? I think, was Python even mainstream 10 years ago?
I don't know exactly. I certainly did not hear of Python when I first got started. Java was, well, honestly, even earlier in my history than that. I did a little tiny bit with QBasic back in the like Windows 95 days. That is what piqued my interest in programming as a child. And then I had the opportunity to learn Java in high school, and I really did not even pick up or know anything about Python until I started that journey as an actual software developer career. When I first started working, I was hired initially to work on Android, and some of the systems that we used integrated with Python, and some of the folks that I worked with were really high on this language and really always professing the benefits and sharing how they thought this neat thing, how neat this thing was, and how it could easily interact with all these external sources. So that was my introduction to it, which was about 10 years ago, was when I started working at this job. And then within the first year or two is when I was introduced to and picked up Python.
And would you say that it was easy to switch from being an Android sort of Java developer to picking up a new language like Python? Was it just learning the syntax, or is there a little bit more to it than that? You have to understand. I'm like on the outside. I can barely code to save my life.
Yeah, it's a really good question. I think that Python is one of the easiest languages that I have ever learned. I will say I am definitely embedded in the trenches. So I've done a lot of programming. I've been kind of naturally inclined to be able to program and learn programming languages pretty easily since relatively young. So I don't have the same experience with it. I do think Python is one of the easiest languages that I have learned. And I do think it is one of the best languages for folks who are new to programming, folks who don't have any experience. It's one of the best languages I think you can pick up first. Um, in terms of my personal experience, I found it pretty easy to switch over. I was working on different kinds of software when I first started writing Python code. It was not doing the same sort of stuff, so it wasn't running on the phone. It was web applications, and it was other sorts of custom digital signage systems and things like that. So it was a different kind of software, but I did find it particularly easy, and I quickly became another one of those people who was always jumping at any opportunity I had to share that language with other folks and introduce it to more folks.
That's awesome. That's a little bit like the meme about vegans or the CrossFitters. How how can you tell if someone's a CrossFitter? Don't worry, they'll tell you. It's almost like that because the Python community really likes to share its love for it, which is quite interesting.
Yeah, definitely. And I always love to see folks doing new and interesting things with it. That's one of the benefits you get from sharing it with new folks is you never know what they're interested in or what they work on, and get a chance to see folks use it for all kinds of new and interesting applications.
So when Scott Shawcroft was on the podcast, he said something along the lines of, "Well, Circuit Python is just Python." But I looked into it briefly, and again, I am not an expert. That's why I'm sort of letting you explain it. But is there an actual codifiable or noticeable difference between, let's say, Python that you would write in VS Code and run on your Windows desktop versus Circuit Python, which is again it's Adafruit's brainchild but open source and designed for microcontrollers?
Yes. So when you are running Python on your computer, of course, you're going to write that into a text file, and then on your computer, you'll have the Python interpreter, which is just the program that reads your text file and executes it for you. So you will run your Python script by telling the Python interpreter that you'd like to run it, and you'll point it towards the file path or something like that, so it can execute that file for you. In the Circuit Python world, that interpreter actually lives inside the microcontroller. So when you save your Python file to the microcontroller, you actually save it essentially in the exact same way as you would on a PC. You save it as a text file. There's a little bit of storage that is made available. Essentially looks like a thumb drive to the computer. So you'll open that up, save your Python file inside of there, and then the interpreter that executes it is actually running inside that microcontroller. It's no longer executing anything on your PC. They are the same language, the same base language. They have the same base syntax. So creating variables, doing loops, calling functions, if statements and logic and things like this. All of those work the exact same way in Circuit Python as they do in what I'll call regular Python on the PC, standard normal Python. All of that stuff works the same way. The main actual nuts and bolts differences are going to be more to do with higher level libraries and stuff. So Python on the PC is a wonderful thing because there are lots and lots, probably thousands and thousands, and maybe even more. I don't know the count, but there are loads of libraries out there for Python that allow you to interact with various things. So, if you want to sit down and write a Python program that interacts with YouTube or Twitch, for instance, there will be a library out there that helps you do this. In fact, there will probably be a number of them. So you don't have to build everything from the ground up. You can go and find some library that interacts with some service online or some particular piece of hardware, or does something that you're interested in doing. These libraries are really the meat and potatoes of how you get stuff done in the Python world. And not all of these libraries that work on PC Python can just be taken over to work on Circuit Python. So there are many libraries that exist for normal PC Python that are either too big or interact with different kinds of things that are not available to the microcontroller, and so it's not possible to use those sorts of things. I would say that's probably the kind of biggest difference that people run into. We have new folks come in all the time, and it's one of the questions that comes up is like, hey, I have this Python script that I made for my computer, and it downloads this thing from the internet, or it uses this API, and now I would like to put it on the CircuitPython device. How do I do that? How can I take this library and put it into there? And we end up having to explain to folks like it depends on what it does. You're probably not going to be able to just use the normal Python library. However, depending on what the thing you're trying to interact with is, it's very possible that at the core of it will be some, API or some protocol that you could interact with from CircuitPython. You'll just have to kind of build your own library or adapt the one that's there to make use of the stuff that's in CircuitPython. So, sorry, that was kind of, I think, a long-winded answer, but I think that's the primary difference is the libraries that you can use with regular Python. They do not necessarily just work with CircuitPython. You have to use CircuitPython libraries with CircuitPython and regular Python libraries with regular Python.
Just a quick interruption to talk about this episode's sponsor, PCBWay. PCBWay has been a long-term sponsor of the channel, and I think they're a good match for my channel because they provide quality PCBs for a reasonable price. You can get boards manufactured up to 100 mils by 100 mils for just $5, including shipping to Canada, $15 US, including shipping to USA, $12 US, which is incredibly cheap for professionally manufactured PCBs. I can personally attest to the quality of these PCBs, and so if you want a circuit immortalized forever, check out PCBWay.com with the link in the description. Now back to the conversation. I don't think it was long-winded at all, in fact. And anyways, we're allowed to here on the podcast. This is like our one medium on the internet where we're allowed long form. It's this and audiobooks. That's all you get.
True. Yeah.
So, no, I really appreciate that. Let me take a quick stab, though, at trying to explain what a library is. So as far as I know, a library is just a snippet of code that the user does not have to rewrite. You can just interact. Like, let's say you wanted to do a certain feature, you wanted to add a certain feature. You could add that library into your code, and then your code would go and sort of like talk to the library, which is just a piece of code that's already written that you don't see. You just add it with your file, and the library will either do the function that you want to do or return you a value, like do calculations for you. And so it makes your code a lot simpler. It's basically using other people's code to interact with your code. And the problem with that is that you have to take all that code in that library and store it where the code that you've written is. And that's the issue, right? Microcontrollers don't have a lot of sort of disk space, so to speak, but it's flash memory. Is that about accurate?
Yep, I think you are on the right track. Everything you said is true. The space is definitely one of those limitations. There are a few other limitations, but your description of kind of what a library is and why you would use it and how it's helpful are spot on. Yeah, for sure.
Excellent. That's actually one of my goals to learn coding is so that I can sort of de-obfuscate what's going on behind the scenes, because I think there's sort of like a double issue, so to speak, with learning to code is the libraries, if they're too good, which they tend to be in something like, something that Adafruit produces or something that Arduino is involved in. If the libraries are too good, I feel like it obfuscates too much of what the process is. And so the code becomes super simple. And so you can get a lot accomplished, but I feel like you don't learn as much as if you understood what the library is actually doing behind the scenes. And so maybe I'm just complaining for nothing, but the way my brain works is I can't just, tell, a NeoPixel to go green, right? Or for the fifth NeoPixel in the line to go green. I would love to know how that's actually done. And that's one of my goals, to learn coding so I can actually understand what's going on in that library, like being able to open the library file, read that code, and understand how those things are functioning. I don't know if you're at that point, because I don't know how complex these things actually are, but that would be my goal.
Yeah, that's awesome. I'm definitely pro folks that make it their mission to kind of understand this stuff and break it down and explain it to other folks in a way that they were able to understand it. I think everybody definitely learns things differently, and programming is a tricky kind of thing to learn. So that's nice to hear. It's always, like I said, nice to hear folks who want to help share that knowledge with others in the way that they found helpful to learn it.
And speaking of that, so Adafruit is known for these actually really nice either boards or board add-ons like hats or accessories to make sort of the electronics coding side of it a little bit more interesting and a little bit more useful and a little bit more simple. So I'll give you an example of what I'm talking about for those listening at home. If you go buy an Arduino Uno, for example, so you get a microcontroller and you get a bunch of pins, which is fantastic because then you can just take those pins and break them out into a breadboard or whatever and connect LEDs. Adafruit to me is more about sort of integrating things together. So you get a board like the Circuit Playground Express, which I have one here, and it actually has peripherals on it. It has some NeoPixels, it has a couple switches, has a accelerometer, etc. And we were talking on the pre-show that I had trouble. Actually, my wife had trouble getting started. Like have that board in her hand, and she really didn't know where to go to make things happen. And you actually had quite a few places to direct newcomers. And so, would you mind just going through the process, like what somebody who's completely new to code should probably do once they receive their shiny new Adafruit board?
Yeah, definitely. So the first thing that you'll need to do with most Adafruit microcontrollers, and in particular, I know the Circuit Playground Express and similar devices are in this boat, is from the factory. They typically come with a demo program on them that is actually not a CircuitPython program. It's written more so like you would write an Arduino program, and it's flashed on there as a test to make sure everything is working before it leaves the factory. So that demo code, that initial trial, is not actually CircuitPython. So the first thing that you would need to do once you get your hands on that device is get CircuitPython loaded on it, if that's how you would like to program it, of course. And the best way to know how to do that is going to be looking in the Adafruit Learning Guide system. Probably the easiest thing to do for folks is whichever device you got. So, for example, the Circuit Playground Express is one of these microcontroller devices. On the Adafruit's website, on the same site where you can purchase that device, if you scroll down towards the bottom of the description, there should be a link in there that's going to take you to the Learn Guide for that particular product. In the Learn Guide for each product, there will be pages that tell you all the information about that product, like the hardware, the pinout, how which pin does what, how it's all exposed, what you're able to do with each one, all of that sort of stuff. Also, those guides will contain the setup information. So they will show you how to get your board plugged into the computer. They'll show you what to press in order to get to the bootloader mode. Typically, that's just like a double press on the reset button for most boards. Once you get to your bootloader, you'll then be able to install CircuitPython, which is basically just copying a UF2 file which you download from the internet. CircuitPython.org/downloads is where you can get that. You punch in whatever device you have, and there will be a couple of downloads there for the latest versions. You copy that UF2 file, just copy paste it right onto that bootloader, which will show up as a thumb drive on your computer. That is going to take a few seconds, blink a few LEDs for you, and then once that's finished copying, the board will automatically reboot, and at that point, it will be running CircuitPython. So the next thing you'll see is the CircuitPy drive. Again, that will show up connected to your computer just like a thumb drive. So you'll essentially see like a, new storage device or whatever, right? On that storage device, there will be a code.py file, although it probably won't have very much in it. There's, I think, just like a print hello world or something like that that gets put in there by default. There'll be a couple other folders and a couple other small text files that get created automatically during the process of installing CircuitPython. But at that point, you're ready to start putting your code into that code.py file and writing it out to do whatever you want. So generally, like I mentioned, all hardware from Adafruit, if you follow the link on the actual product page, it will take you to the guide that does that. However, I will say, maybe you got your hardware from somewhere else. You're not familiar with the Adafruit website. I know these devices are sold in some stores at least. So if you found it a different way, another thing that you can do is if you just go to the Learn system, there's two really good spots to look for folks that are brand new. One of them is a Learn guide titled Welcome to CircuitPython. This guide contains a lot of the information for like really, really brand new folks. So all the recommendations for which software we recommend folks to use for editing your code. Of course, though it is just a text file, you can use whatever you like. But all of those sort of setup recommendations and high-level information about what the project is and what you can do with it is in that Welcome to CircuitPython guide. And then the other one of the two places, which is really good for beginners, is called CircuitPython Essentials. So if you search that up in the Learn Guide system, that will take you to the CircuitPython Essentials guide. And this guide basically is once you've started coding, this is going to show you all of the stuff that you can do with CircuitPython. So let's say you want to make RGB lights turn a certain color or something. There will be a section in this Essentials guide called NeoPixel. You go to that page and it will show you how to interface with those RGB LEDs to set them to whatever color. Another example, if you wanted to make a servo move or something, there will be a section in that Essentials guide for servos. You click over to there, it'll show you how to wire it up, it'll show you which libraries to load on your device, and it will give you the sample code for doing the most basic thing to get you off and running with whatever robot it is you're trying to build. So those are the two probably best places that I could point folks towards are the Essentials guide and the Welcome to CircuitPython guide. But of course, like I said, too, for any specific hardware you have, there are also product guides which mirror a lot of the same information and tailor it for those devices as well. So that product page, the link in the description there that takes you to the product guide, that is always a safe bet as well for any particular hardware you have.
I have to say, too, for anyone looking at the product page, there's a lot of links on the product page. It's at the very bottom, right before the videos, at the very least on the Circuit Playground Express. So kind of easy to miss there, but it's just after all the details of what's in the board. And then actually navigating that file is pretty easy. It's just, there's sort of like a table of contents over on the left-hand side once you're on that page. So everything is pretty good there. Follow the steps and you should be able to get started. What kind of IDE? So I guess IDE might be a little bit too technically charged. What should new people be writing their code in if they're interested in Circuit Python? Because I'm aware, I think you can just literally type in in a text editor, but what do you recommend people use?
Yeah, great question. So for folks that are new, if you don't have any prior programming experience, if you don't necessarily consider yourself, quote unquote, a computer person, if you're not super comfortable moving around and doing stuff on computers, the thing that we recommend is an application called Mu. MU is the name of that, and it's a very basic editor, IDE, integrated development environment, for anybody that doesn't know that term, but it's basically just a program that you use to write programs. It's a text editor. It's got some helper features built in, like syntax highlighting, that will turn your code pretty colors to let you know if you've made mistakes or not. in this case of Mu, and one of the things that makes it really good for new users is it also contains the CircuitPython serial console, which is where you can get debugging feedback. So if you are writing your program and for whatever reason it's not working how you want, in the serial console is where you're going to find the logs, the error messages, all of that sort of stuff to try to troubleshoot it. And Mu builds that in all in one so that you don't have to worry about getting connected to that separately. So Mu is definitely the place to start if you are new and want the easiest thing to do. I will say for me personally, I don't use that one as much. I tend to use an IDE called PyCharm, which is a fully featured IDE made by I think their name is JetBrains, but they're actually the company that made Android Studio, which is the authoring tool for Android apps. That's how I found out about them. That's how they got me into their ecosystem. And then I found that they had a Python specific IDE, and I started using that, and I've been using that for many years now. And I find it quite nice. It's definitely really good if you are going to be kind of the next level up, so to speak. So, if you're just interested in making a CircuitPython project, and not getting involved much beyond that, then Mu is definitely the place to go. But if you're interested in maybe contributing to CircuitPython or working on the open source software portions of it, then a more fully featured IDE that has integration with Git and version control and things like that can definitely make your life a lot easier.
I'm actually going to link all the stuff we're discussing in the description below, just so that people have an easier time finding it. But you did talk about contributing into CircuitPython, and so that actually brings us quite well along as to what you actually do for CircuitPython. Do you want to talk to us a little bit about what your job is specifically?
Yeah, definitely. So I am a member of the team that works on CircuitPython. I work on the software. Generally, so I work full times on CircuitPython for Mondays, 1 day a week. So today happens to be a Monday when we're recording this. So I'll look at kind of my average day, so to speak. I will be doing PR reviews. So when members of the community want to contribute code into the project, they will submit that as what's called a pull request on GitHub, which is basically just them saying, "Hey, I wrote this new code, and I would like to share it and potentially have it included in the library or in the project or whatever." So I will look through those things. I will be testing stuff out. I'll be looking over code, doing reviews, trying to figure out if there's any issues or if there's any things that need to be done differently or changed or any of that sort of stuff. So that is like a big part of my Mondays, is going through all of the CircuitPython libraries, the Python code, the libraries, just like we were talking about before, looking through all of the contributions and just testing and reviewing that sort of stuff. Beyond that, though, that's kind of like a good chunk of my days week to week on Mondays. Some other stuff that I work on is CircuitPython projects. So building those projects that go into the Learn Guide, all those specific tutorial pages and things like that. That is something that many folks who work for Adafruit will create those Learn Guides and have them published into there. So from time to time, I'm working on those. Working on documentation, which is not quite as glamorous as some of the other stuff, but is still very important. Keeping the docs up to date, fixing any issues in them, even doing work in the infrastructure so that we can, more easily generate documentation automatically and stuff like that. Working on all sorts of stuff like that. There's a weekly meeting which occurs on Mondays. So for about an hour to an hour and a half, just depending on how many folks attend on a given day, we'll have that weekly meeting, which occurs out in the open if anyone's interested in listening in or participating. That's over on the Adafruit Discord channel. So that's a chunk out of my day. And then beyond that, it's just like new code myself, right? So I spend time reviewing the stuff that other people propose to add, but then I also spend a chunk of time working on code for myself. So either making changes inside the core, which I'm relatively new to. That is the C code that actually is CircuitPython. So that's the C code that is the interpreter that runs on the microcontroller. I am relatively new to that, but I have been getting a lot more involved with that this year, getting my hands and feet wet, so to speak, in that world. Um, I've worked on publishing some of the libraries. I've worked on publishing some libraries that are in the community bundle, which is code that is published and everyone is free to use it, but it's not owned by Adafruit. It's just published by individual users, and then it's added to this bundle so that everybody can still see it and make use of it. So all kinds of things like that, but yeah, I would say the most typical things I'm doing are either reviewing contributions, making my own contributions, or working on some of the periphery stuff. I run the meeting every few weeks. We have a rotation of folks that run the meeting. So when it's my turn to do that, then I will host, do that sort of stuff. But those are the kinds of things that I tend to get up to on Mondays when I work for CircuitPython.
I really appreciate you talking about how you're working on sort of the interpreter side, where the Python gets turned into, I guess, machine code. I assume is that accurate?
Yes. So I will say I am still relatively new to all of that stuff, and so I can't necessarily. I will say fair warning. Like what you get is my interpretation of it. So I believe you are correct, but I
Yeah,
could
that's
certainly be
okay.
wrong as well.
But that's literally what I'm thanking you for, is being honest about the fact that you don't know everything, and
Yeah.
you're still good enough to get paid to do the work. And this is something that I feel like I myself have struggled with it, and a lot of people in my audience have struggled with it, feeling like they need to know 100% of the job before they go and apply for the job, which I think is nonsense, because the whole point is to be competent enough to figure out anything on your job, right? You're not supposed to be the expert walking through the door. You're supposed to work towards being the expert. And I think more important than, a deep visceral knowledge of whatever your job entails is the ability to be adaptable to whatever your job throws to you. And I really appreciate when people, are in jobs that people, students would be looking at saying, wow, I wish I could do that for a living. It's really refreshing when people share the fact that they are learning on the job, because I believe that's what most of the employers expect you to do anyways. It's just not clear to everyone on the outside that that's an acceptable thing to do. So I really appreciate you being honest with that, because it really helps people sort of you know go reach for a goal before before that they feel that they're 100% at it, which is awesome.
Yeah, thank you. Yeah, I totally agree. I appreciate you mentioning that. I will say for the past probably just over a year, starting in early 2021, I started streaming, and one of the things that I learned from that is that being able to learn and fail in a public setting, and I don't have a large audience or anything like that, so it's a couple of folks watching along, but being able to learn and fail in a public setting like that um, is first of all scary, kind of terrifying when you first start doing it, but it's actually really nice because folks are willing to help you learn. Right, I've learned so much from folks who see me do something one way and it's wrong, or I start working on something and say I don't understand it. And I've learned so much from the audience being able to give back in those moments. Um, but that's something that I'm glad you mentioned it because I'm passionate about that idea as well. I think it's good to let folks see your failures, right? It's not, again, it's not the most glamorous thing in the world, but nobody knows everything. Everybody is always in a constant state of learning, and I think, yeah, I mean, to your point, I think it's good for folks to be able to see that. I think a lot of times we can get in our own heads and think that everybody other than us just knows everything and is perfect at everything and was able to pick it up and do it, just right the first time. But I think it's not like that necessarily for too many people, and I think it's good to let people see that. And that's definitely one of the positive things I've gotten out of streaming is being able to fail and be okay with it, and let other people see it and let them learn from it as well.
Absolutely. There's a Canadian woodworking YouTuber called Matthias Wandel, and he's usually given criticism in his comment section, as everyone who posts on YouTube has experienced. But he made a video recently saying that one of the common criticisms he gets these days is that he makes more mistakes these days than he used to. And his reply is that he used to think of himself as an instructional channel. And so, as an instructional channel, you want to show the right way to do things. So, when he made mistakes, he just fixed them and showed the resulting of the doing it the correct way. But now he sees that he's more of an entertainment channel, and that mistakes are entertaining. But he was telling people how how he makes more mistakes because he's got kids, and he's trying to hurry up and get stuff done and make videos, and it's not that big of a deal. And it just resonated with me because this guy has built incredible machines out of wood, stuff that like you would never expect. Like it's not a winter Gaton level of machines, but like he builds his own shop infrastructure like belt sanders and stuff like that out of wood. And to see someone like that make mistakes still to this day after thousands and thousands of hours woodworking is actually, to me, refreshing, and not it's not diminishing of his abilities, because who cares if you're going to make mistakes? If you look behind him, there are machines that he could easily charge tens of thousands of dollars to build, that he built himself. And so who cares if this panel gap is not quite right? He could do it right, but why iterate like 8 times when it's such a little thing, right? So
Yeah.
I think it's important that we keep our eyes on the prize and understand that everybody makes mistakes, and it's actually a healthy part of learning. And also to not sweat the little things, because honestly, if you never make mistakes, how do you think you're going to be good at fixing mistakes? It just doesn't make sense.
Yep. Yeah, definitely 100%.
That's the bad part about YouTube, is that a lot of it is like really edited, and people hide their mistakes very well. And I mean, I tell my students, I'm a automotive professor when they contract me to do so, and I tell them like, believe me, I've broken more bolts than you've seen. So like you'll get there eventually. Don't worry about it. You know,
Yep.
we'll fix it. And the only reason I know how to fix broken bolts because I freaking broke them on a Friday afternoon when the customer needed their car.
It
It is what it
happens.
is, man.
Yeah, you can't really make things without making mistakes. It's just it's part of making anything. I think is messing up sometimes, and honestly, learning that process of how to troubleshoot and how to figure out what's wrong, I think, is invaluable as well, and not probably taught as much as it should be. So, I'm happy to show my way through stuff like that to folks.
Yeah, and I think that's really refreshing and necessary. And so you were talking about there's like a community bundle, right? So let's say I code something in MicroPython where whenever you change the color of an LED, like let's say I code something where you send a command to change color of an LED, but when you do that, it also pops up on your connected display that it insults you. It calls you like a poopy pants or something. Is that something I could submit, and then someone like you would have to review and approve? Is that how that works?
Yeah, so for the community bundle specifically, anybody is allowed to publish their own library and ask for it to be added to the community bundle. There is a very minimal amount of requirements, so to speak. Your repository needs to be set up in a specific way that the bundle knows how to handle it. And we have, again, there's a learn guide for that. Learn guide, I think it's called Creating and Sharing a CircuitPython Library, that covers the process for doing that. But beyond setting it up in such a way that our infrastructure is able to work with it, anybody can create a library that does whatever they want and publish it, and we could add it to the community bundle. I probably will get myself in trouble if I say anything would be fine. I'm sure there are things that we would prefer not share in that way, but you're certainly free to make it and publish it. but pretty much anything that's not derogatory or anything like that is going to be fine for the community bundle. And so I would say something like that, even insulting on the screen, like I find that kind of amusing. I don't think there would be any issue with that. So you totally could make that. You could submit it as a pull request to add it to that community bundle. And then, yep, that would be one of the things that comes across my desk on a Monday. I would see it in the list there and try it out, look it over and approve it. And then it would be listed in there. And then once it's in the community bundle, one of the upsides to that is it will then be available to download as part of the bundle from circuitpython.org. There's also a command line utility called circup, which is a way to install libraries on your devices. That's very convenient if you are familiar and experienced with computers and terminal interfaces. And once you publish your library and get it added to the community bundle, you're then able to install it very easily. Anyone is able to install it very easily using that circup utility. So, yep, you've got the process nailed down.
Interesting. And you also talked about how you work on Learn guides. Is there any, first of all, can you talk to us about a couple of the projects that you've contributed and maybe let us know which one is your favorite that you've made?
Yeah, definitely. So the Learn guides are kind of core to the Adafruit experience. Honestly, a lot of things kind of start with the Learn guide. Somebody will have an idea for a project. Hey, I would like to make this thing that does this stuff, and that is what drives everything in the CircuitPython world. If it's a new thing that's not possible to do yet, somebody dreaming up the idea for the project is kind of the first step along the way of making it into a reality. So there are loads and loads of guides out there. I think we're up over 1,000 at this point as far as total Learn guides that show different projects and things like that. So there's something in there for everyone. A couple of the ones that I have worked on. So there is some of the more recent ones are a PyPortal Winamp MP3 player. So PyPortal is an Adafruit device that's like a all-in-one sort of, I think, 2.5, 3-inch or so touchscreen device. It's got a resistive touchscreen on it and a color display. It has a Wi-Fi chip on it, so it can access the internet. I made a Winamp player, in air quotes, so to speak. So basically, what this is it's not fully functional, it's not fully featured, it's not meant to be. It's just supposed to be a bit of a hit of nostalgia for folks that might have used Winamp back in the day. And so what it allows you to do, though, is play your MP3 files from the PyPortal, either through a plugged-in speaker. There's a little two-prong plug on the back where you can plug in your own speaker, or there's even a built-in, much smaller one, which you can listen to them come out of that small speaker as well if you want. So it will play your MP3s. You load them up on the SD card. It will show them to you in the list, and it will cycle through them. It'll show you the time as it seeks through. So just the most basic functionality, but the coolest thing about it is that it utilizes Winamp skins. So there is, I should say, an online website, which just is kind of a library of old Winamp skins. Because one of the things from back in the days of Winamp was programs tended to have these like skins, these very customizable interfaces. So, there are thousands of different Winamp skins that people made, and the members of the public were allowed to make these and share these. That's how we got so many of them. And some of these old relics still exist. You can still find this old skins library. So the way that I created this project was you could actually go and grab whatever skin you wanted from this library and run a little converter script on it, and then put that one as the skin on your PyPortal. So if you made your own back in the day, you could use that, or if you used one that you remember from your childhood or something, you could go and download that from the library, put it on your PyPortal, and use that.
Well, that sounds like that project really kicks the llama's ass.
Exactly. Yep. It was a fun one because it was something like I remember using Winamp to play MP3s like back in my middle school days, and so that was fun to work on something related to that, to work on something that got me thinking about that time period again. Was a fun project. Another one I did recently was a Game and Watch implementation. So Game and Watch was a very old Nintendo handheld line of devices. I created a Game and Watch Octopus game. Octopus was one of the games that Nintendo released on these little handhelds. I made a Circuit Python implementation of that runs on a Pi Gamer, which is like a handheld Circuit Python device. So I never did play the original handheld, but it was fun to look back on that project, learn about it, and then make an implementation of it.
It looks really neat. You did you design the 3D printed case for that as well?
I did not. Nope. The 3D printed case, I do believe it is an Adafruit design made by another member of the team. Noe and Pedro are brothers that work at Adafruit that do a lot of the 3D printing stuff, right? All the modeling and the streams and the learn guides that are related to 3D printing. I believe that they modeled that case. So it is an Adafruit part, but not something that I worked on.
Gotcha. Looks, but it looks really good. I mean, uh, in the Learn article, there's the actual, or the Learn guide, I should say. There's a picture of the actual Game and Watch, and I mean, the whatever's on the screen looks identical, which looks really good.
Nice. Yeah. Thank you. Yeah, I did. It took a little while of pixel pinching, so to speak, to get the graphics just right. But yeah, I was really happy with the way it turned out on the screen, and we kind of have that. It was important to me when I was working on that to even though we have like a full color display, to really make it look like that old school sort of LCD where it can just sort of turn on and off the black section. So the graphics are capable of much more, but I in this case made everything to look like that sort of old school LCD on off sort of vibe.
So the picture of this is actually, it looks to me like it's in between two frames because there's sort of like the ghost image of some of the tentacles that aren't active on the octopus. Uh, is it not between two frames, and you actually designed it to look like there was segments there that could eventually turn on?
Yep, that's the latter of those two. That's absolutely right. Yep. So you see those, and it is an option, so you can actually enable or disable that mode. But yep, it draws those little faint outlines that essentially, like if you were playing the original handheld, if you tilted it at just the right angle, you would see those sort of grayed out sections where it's eligible to be turned on. And yep, I did the graphics include those in one of the modes when you play the game.
You know, that's just a level of dedication and nerdery that I just cannot tell you how much I appreciate that level of attention to detail. Not everyone is going to, use this guide and email you and say your implementation of this is epic, but I'm here to tell you that is some next level nerdery, and I am here for it.
Yeah, that's awesome. Thank you. I really appreciate that.
That's, it's I'm a car guy, and I'm more of a Honda guy. I'm a big fan of Honda's stuff. Not so much these days, but before. And Honda was never the fastest car around. It was never the best value car around. It was never, the most anything car. But what I really appreciated about Honda's designs from about the mid 80s up until the early 2000s is the attention to detail. The lines are all very purposeful, put there for a reason. The setup, the noise the car makes, the the handling characteristics, even on the economy models, it's that level of detail that I just come to appreciate. And so you can't imagine how much I appreciate the little detail you added into this. This looks awesome. I love it.
Yeah, thank you. That's great to hear.
And okay, so you've got the Winamp one, which if the people at home missed, I did a Winamp reference with the llama. You've got the Game and Watch. Is there any more that you'd like to show off?
Yeah, the other one I'll mention is the one that I would say I probably am most proud of. One of the ones I had the most fun working on is a guide that shows you how to build. It's called Creating Your First Tile Map Game with CircuitPython. So, tile map game is kind of a genre of gaming, sort of 2D grid sort of graphics. You have a character that can move around, and then tile map is a reference to how the graphics are drawn onto the screen. And so this guide, it walks you through the process of creating a sample game, but even more than that, really what it's aiming to do is give you the tools to create your own game. So throughout the guide, it lets you make a game where you move around Blinka, which is the CircuitPython snake character. You move Blinka around and you try to collect the little resistors, and you try to collect the hearts, and you have to avoid the Sparky, which is kind of the bad guy, the let the smoke out of the component by giving it a bit too much power or whatever. So you have to avoid Sparky, collect the hearts, and collect the resistors, and then the resistors allow you. They're kind of like a key, or essentially they give you safe passage through Sparky. So you pick up the resistor, and that allows you to pass through one Sparky without getting damaged. And so you kind of have to get each one for however many times you need to pass through them. Which is just a very basic little game, but really the thing that I'm most proud about that with is it gives people the tools to be able to create that style of game in whatever image they can imagine. So it walks you through a way that you can create your maps just using Excel. You don't need to have any kind of fancy specialized software or anything like that. Just put your map together in a spreadsheet. And I probably shouldn't even say Excel, because you could definitely just use OpenOffice or Libra or whatever spreadsheet program you want. You can save that in there, and then set your sprite sheet up and get everything loaded, and it walks you through how to create that game and write the code that decides how all the individual components are going to interact with each other. Like what happens when the character runs into this thing. Shows you how to set all of that sort of stuff up in your code. So that's definitely, it was a while ago now when I worked on it, but it's one of the ones I look back on fondly. And it's one of the ones where I've got a kind of a more advanced one in mind that I hope to do one of these days.
Really neat. I would actually encourage the audience out there to Google Adafruit Sparky, because they're going to come up with an Adafruit logo that has been used on someone very popular's YouTube channel. Not mine. I'm actually talking really popular. So just a little bit for the people that they're at home. They'll check out and they'll see what you mean by Sparky. But yeah, I think that's really neat when you put the power of creation into someone else's hands, right? So not only are you doing this tutorial, but once the tutorial is done, the person will be able to continue to create games, I guess, right? Like it's just They can change the location of things. I'm guessing since you use a spreadsheet, it's your code is reading comma separated values to figure out.
That's correct.
Where the stuff goes. Okay.
Yep.
There we go. See, I'm getting there. I'm getting there. I may not know how to open a file in any kind of programming language, but I definitely know what comma separated values are. So there we go.
Nice. Yeah, very useful. Comma separated values,
Yeah. And I guess I have a question that I ask every single one of my guests. I guess now is the time that I would ask you. Do you mind if I pop you the question?
Yeah, definitely.
All right. So you get unlimited funding to start the business of your dreams. It doesn't have to be profitable, but does have to provide a service or create a product. What kind of business do you start?
Yes, I've given this some thought once I heard this on your show before, and I think the answer that I came up with is we don't necessarily invent a new thing, but what we do is we greatly expand libraries. Obviously, libraries already exist, but if I had infinite money, what I would do is expand libraries. So not only more books, but other types of media, movies, music, software, but even beyond that sort of stuff, like outside of media. I think some of the libraries around me actually have tools and things. Like I rented a kilowatt, a little electricity meter from the library to measure like how much power a certain accessory uses or something like that. Which is a thing like I had no idea this was a kind of thing you could get from the library. I don't even know how I discovered that, but there's other sorts of little tools and widgets like that. even some like hand tools like saws and wrenches and things like that you can actually rent from some of the libraries around here. Another one of the libraries, I think at one time they had like a collection of cake pans, like specialty shaped cake pans, which is not necessarily a thing that I have much use for, but I thought that was super fascinating and interesting, of a thing for the library to have. But the main thing is, I think libraries are one of the last sort of bastions in modern culture, at least in the part of the world where I am, that are, you can just go and do stuff. Like you receive stuff and you're not necessarily expected to pay. You're not necessarily just bombarded with advertisement while you're there, um, in the same way that you are other places, at least. um, I think libraries are a wonderful thing, and I would love to see like all sorts of new stuff made available at them. I would love to see classes offered that teach people how to use all of this stuff, even things like power tools and stuff like that. Like um, my father is into like woodworking and fabrication and power tools and things like this. It's not a thing that I ever got too far into, but I am interested by it. I respect it, and I think I love to see the things that people can make with it. I think it'd be awesome though if the library had even some selection of tools like that, and you could go there and be taught how to safely use it and have someone show you the ropes on how to do it, and you could go there and make your cuts, or do whatever you need to do on the tools that are there, make welds or something like that. I think having all of that sort of stuff at a public location that we all agree is important and agree to fund just for the sake of existing and making everyone's life better, would be awesome. So I think that's what I would do, is I would try to expand and add as much as I could to the existing library infrastructure, both new buildings, but new stuff inside the buildings, and expanding the collections, and just offering anything and everything I can think of.
Yeah, that's really cool. That's actually a really cool twist on a lot of makers I have on here. Want to start maker spaces, but it's true that libraries are already taking up some of these services, and yeah, you could rapidly expand them. For example, I encourage the people listening to go check out what's in your local library, because I know here in Ottawa, Ontario, Canada, where I am, we can get museum passes for the library. So there's
Nice.
probably a 6 to 8 month waiting period because there's a massive waiting list.
Yeah.
But yeah, there's free access to museums, which is, I mean, let's be honest, some people with lower socioeconomic status, that's the only way they're going to be able to go see the museums. And so
Yeah.
I think it's really good that the library is offering that. We also have 3D printers where you don't pay for the time, you only pay for the material. So if you have a 12-hour print, you put it into a queue and they call you to pick it up when it's ready. And if you think a kilo of filament up here in Canada is about $20 to $30 for just regular PLA. So if you're using a couple hundred grams, it's only going to cost you, under $10. And to have a bespoke piece of something that you've either downloaded or created yourself, that's an incredible value. So yeah, check out what's in your local library. I totally agree with you.
Yep, definitely. My local library has got the makerspace going on with 3D printers as well. And I know for a while we were lucky enough that there was a big local company that was even sponsoring the filament, so you could even go and print stuff out literally for free. I don't know if they're still doing that, but for at least a few years they were doing that around me, which was really cool.
That's super cool. I think if my YouTube channel ever grows into something that's large, I guess thinking 3D printing nerd sized, or maybe like definitely if it's something the size of Linus Tech Tips, which would never ever happen, but if it did, I would love to be able to start my own makerspace, because at that point, I mean, it's all just a business expense anyways. So you're paying like, at the end of the day, you're paying like 30 cents for every dollar you're putting into it. It's only about 30 cents leaving your pocket. So it's like you get to do way more good with the same amount of money, or you get to pay a lot less money to do more good type thing.
Yep.
So yeah, I think if my channel ever becomes that successful, the two things I would want to do is support open source initiatives and give back to the local community, because I think that's really important, especially like exposing people to stuff they wouldn't be exposed to.
Yeah, definitely.
Cool stuff. So, do you have any closing thoughts? Let's actually. Well, we forgot to do something. We need to direct people to your live streams and stuff. Can you talk to us a little bit about what you do on your live streams?
Yeah, definitely. So I have a weekly live stream for Adafruit, which is on Friday evenings at oh, I'm going to mess up the time zone. So it's at 4 p.m. Central Time, which is my time zone, but it's generally billed in Eastern and Pacific. So it is then 5 p.m. Eastern and I think 2 p.m. Pacific, but don't quote me on that one. That's on the Adafruit channel, both YouTube and Twitch. It's the Deep Dive program. That's actually a stream that was started by Scott Shawcroft, the lead developer of CircuitPython and prior guest on this show. Scott took some time off this year. Him and his partner had a child, so he had a couple good chunks of parental leave for the year, and he, cut the streaming out of his schedule. And I took that show over on Friday evenings, Friday afternoons. During that show, we're working on whatever I happen to be getting into for the week with CircuitPython. So often it's the exact kind of stuff we were talking about earlier: PR reviews, development of new libraries, testing of new things, trying out the latest and greatest stuff. That's the kind of stuff we do on there. I stream on my own. FoamyGuy_Twitch is my own channel. On the weekends, typically Saturday morning at 10 a.m. Central Time is kind of the one sort of set schedule time I have each week. But I pop on here and there throughout the week as well. And that tends to be, again, the same sort of stuff, just reviews, working on whatever projects I have going on, testing out new CircuitPython stuff, building circuits to test some new PR or whatever is on the desk for that week. So if folks are interested in kind of the other side of the coin of what happens after somebody makes a contribution to open source code, like where it goes from there, that's the kind of stuff that you can see pretty typically on my streams.
And so you said Fridays at 4 Central Time?
That's correct. Yep.
So it would be 5 p.m. Eastern, 2 p.m. Pacific. And then you said for your personal streams, it was at 10 a.m.,
10 a.m.
right?
Central Time. Yep, which is
And so that would be 11 Eastern and 8 a.m. Pacific. So I was just looking that up. So we want to get people in the right spot at the right time.
Yep. Yeah, appreciate it. Yep. Come and enjoy a cup of coffee with me while I work on stuff Saturday mornings.
That's cool. I have my own live streams that I finally started. So I have been seeing a couple of other people coming through. So that's really appreciated. Just talking as a live streamer, it's always more fun when there's people contributing to the conversation. So if you go visit Tim's stream, I would encourage you to interact with people that are there. I know personally, Johnny Bergdahl is probably going to be there 9 times out of 10. He's a cool guy too. So, have a conversation, meet some people, and you'll probably learn some stuff at the same time. So highly recommended to go to live streams for makers that you enjoy their content, personally at least.
Yep, definitely. 100% agreed. I'm looking forward to watching some of yours as well. I didn't realize that you had live streams going. So I've got you followed over there on Twitch, and I'm looking forward to watching along with your streams as well.
The Twitch ones are way off topic, though. I'm just playing Gran Turismo 5.
I see. Okay.
The electronic ones happen on, oh, geez, there's a link in the description, but it's at SE Streams, I think. It's basically, I just, my Patreons asked me to make a different channel for all the live streams. And plus, it's kind of ragtag, so it's not super well produced, but that would be every Thursday at 1 p.m. Eastern, which would be 12 p.m. 12 noon, I should say, Central Time, or 10 a.m. Pacific. and that's on the channel linked in the description. If you're interested in electronics, that's the one to come to.
Nice.
The Gran Turismo one is it's just it's me pretending I'm working when I'm actually playing video games. That's what it is.
I gotcha. Well, I'm
All right,
interested in both, so I'll be around.
there we go. You'll see me smash into the wall in a 2009 Corvette pretty much all the time. That's kind of my thing. Well, I thank you so much for taking your time and coming onto the podcast. And I hope that people will go and check out your stuff. And I especially hope that they'll take up Circuit Python. At some point, I need to stop being a big baby and learn it. So at that point, I'm probably going to make some tutorials. But I'm going to take a look at the learning modules as well to get me going. And so, yeah, anything you want to leave the viewers with?
Nope, I think we covered everything. Just definitely thanks to you. I really appreciate you having me on and having this conversation. It's been great fun.
No, truly, it was my honor, and I hope that everyone goes to at least check out some Adafruit stuff and check out the live streams, and they go say hello. Make sure, guys, if you go to the live streams from this podcast, make sure to let Tim know where you heard of it, because that's always cool to know where the viewers came from.
Yeah, definitely. Thank you.
Thanks for watching, everyone. We'll catch you on the next one.